Hey guys, this is Mr. H. Hey, I am going to do another video on the difference between linear and arithmetic sequences, exponential functions and geometric sequences, and also the difference between arithmetic and geometric. So it's a bunch of questions that I'm just going to jump in and do for you. So that's going to be our next assignment. So here, I'm going to pull this up and let's get going here. First thing I want to do is I want to be able to tell the difference between a sequence and a function. All right, a sequence is discrete points because you can only have whole numbers for your inputs. Whole numbers for your inputs, that's the thing that makes a sequence a sequence. Now this is a linear function, so it's continuous because there's no breaks. Domain is basically all real numbers. And this is addition because it's a straight line. And we can say that this is a linear function. Okay, so boom, submit it. Now, next problem. All right, so you can see that this is a bunch of discrete points. And it would be nice if there was one more over here, but it's not. So we can see that it's going down. It's definitely not linear. So we're going to say this is discrete. This is not continuous. This is discrete. And it looks like it's whole numbers. So it's 1, 2, 3, 4, 5. So this is definitely a sequence. And what we can say is that it's multiplication because it's a curved sequence. And that means it's going to be geometric. So basically this is a exponential function, but it's the geometric sequence. It's a subset of exponential functions. It's a particular subset, and it's very specific because it has only whole number inputs. So that's what we got here. So boom, let's go. Now, next question. Let's do a couple more. Okay, again, this one is a set of discrete points. It's not continuous. And so we're going to say it's discrete. You can also see that it's curving. So that means that it is, well, the inputs are whole numbers. And then, so we know this is repeated multiplication. In this case, it's going down, so we're multiplying by a fraction. And then it says, that means that it's a geometric sequence. Boom. Okay, let's do a couple more. All right, so this, again, this is discrete, but it looks like it's a straight line. So this is going to be an arithmetic sequence. It's a subset of linear functions, but it's a very specific subset because it's discrete points and it's all whole numbers. The inputs are 1, 2, 3, 4. There's nothing in here. There's no input between 1 and 2 or 2 and 3. It's only whole numbers. That's the key for sequences. And then we're adding the same number, which means it's an arithmetic sequence. Boom, done. All right, let's see here. I'm going to do one more. All right, again, we got another geometric sequence because the way I know that, it's discrete points, right, which means it's a sequence, and it's curved, which means it's not linear. All right, so we got discrete points. It is whole number inputs. It has multiplication, and that means it's a geometric sequence. All right, boom, done. All right, so now I want to go to this now. I want to look at this and figure out what kind of sequence it is, right? Now, I'm going to use the little pen they provide. So first thing I see, so it's going down by a -4. 6 minus 10 is a -4. 2 minus 6 is a -4. So I know that this is going down by a -4. So this, I can stop this. Oop. This is a arithmetic sequence. It has a common difference, and the common difference was equal to a -4. All right, so I submit that, and it says, nice job. All right, let's do another one. All right, this one. Okay, first thing you should do is always check to see if it's linear or arithmetic. So what I'm going to do is 3 minus 1 is a -2. Actually, 3 minus 1 is a +2. 9 minus 3 is a +6. So this is not linear. It's not arithmetic. So I can go back and I can erase this. But now what I'm going to do is I know that it is arithmetic or geometric. So what I'm going to do, oops, I don't want that. So I want the pencil. So 9 divided by 3 is 3, and 3 divided by 1 is 3. So I can now answer this like so. So this is a geometric sequence because we're multiplying by 3. It has a common ratio. 9 divided by 3 is 3. 3 divided by 1 is 3. And that is the common ratio, 3. Boom, done. All right, let's go. What else we got here? Let's do a couple more. All right, how much time do we got? That's about 5:30. All right, so here, this one looks like it's an arithmetic sequence. Again, what we got here is it's going down by a -7. 10 minus 17 is a -7. 3 minus 10 is a -7, right? So that means that this is going to be a -7. So let's go ahead and fill this in. So this is an arithmetic sequence, and it has a common difference. We subtract it, and the common difference is a -7. Boom, done. One more, and then I'm going to wrap it. All right. I can see that this is not changing by the same amount, so it's not arithmetic. It must be geometric. So what we're going to do is we're just going to divide. So 3 divided by 18 is 1/6. And 18 divided by 108 is also 1/6. So my common ratio is 1/6. That's what I'm putting in there. So let me erase all of this and enter. So this is a geometric sequence. The common ratio is equal to 1/6. It's going down. And I think that's enough. That's about 7 minutes of problems. Okay, I think that's it. Let me go back and see if there's anything else I wanted to do a quick take on. Let's see. What's this guy? This is kind of the same idea. They're just asking us to find the common ratio. Or the common difference, right? So all you're going to do is you're going to do a -20 minus a -12, which is a +8. And then you're going to do a -12 minus a -4, which is going to be a sorry, I said that wrong. A -20 minus a -12 is going to be a -8. And a -12 minus a -4 is going to be a -8. So that's the common difference. The other way of saying this is it's going down by 8. That's what you should see. All right, I'm going to do one more since I kind of goofed up on that one. This is common ratio. So the way you find the common ratio is you go 36 divided by 12, which is 3, and 12 divided by 4, which is 3. So it's increasing by a factor of 3. Boom. That's it. So arithmetic sequences and geometric sequences are very similar to what we were doing with linear functions versus exponential functions. Arithmetic sequences are a subset of linear functions, and geometric sequences are a subset of exponential functions. But they're very specific, only whole number inputs. All right, I'm going to stop and I'm going to post this.